This is part 6 of the Earth's Resources topic. It's the final part of this topic on GCSE AQA Chemistry. It's a dual award and triple award topic. I'm going to recommend you have a go at the activities as we go through, pausing as you go. So in this final video, we're going to take a look at the reduce, reuse, recycle choices that we have. We need to know that by using less, by reusing materials and by recycling materials, we can have a positive impact on the environment. And also we can look at how we can make the most of the limited supplies of metal ores that we still have. The aim of recycling campaigns is to preserve limited resources, limit energy usage, and reduce the amount of waste we produce. There is a lot of crossover amongst what we're going to see in this video. A lot of very similar ideas, quite repetitive, but I think it's important that you understand how similar some of these ideas are. So let's start by dealing with this, identifying whether the materials in the table are renewable or non-renewable. And we've got paper and wood, which are renewable. They both come from trees. The rest of them are non-renewable. Metals we get from the ground, plastic from crude oil, building materials from the ground. Glass comes from sand, soda, so we could run out of it. What are the advantages of recycling materials such as glass and plastic? Well, in the first instance, what it does is preserve remaining resources and preserves remaining raw products. That means we can carry on making more new for longer. There's also less waste that will go to landfill, because if we fill a landfill site, we then have to find new landfill sites, and the opportunity for that gets harder and harder as time goes on, because you've got to fit very strict environmental criteria, and people don't really want a landfill site near their home. But why might reusing in this instance be better than recycling for the environment? Well, even in recycling, you might think that you're going to melt something down and reset it. There are still energy costs. We don't want those energy costs. So if you have a milk bottle that gets delivered to your door in the morning and you leave it there, it can be cleaned, it can be refilled, and it can be brought back to your home. So potentially that is a way that we could do even better than recycling. So now let's move on specifically to aluminium. And again, we're thinking about why we should recycle. First of all, on the basis of sustainability. I did say there was going to be similarities. If we recycle aluminium, it means we're not putting aluminium product into landfill. We're not filling it up. But also recycling, we are retaining aluminium ore that we don't need to dig out yet. So we're making the original raw materials last longer. Why is it important from the perspective of energy consumption? Well, electrolysis is used to extract aluminium, incredibly high energy costs. Recycling aluminium does require energy, but significantly less. We've got here what we do with scrap aluminium. We feed onto the conveyor, into the shredder, we decoat it for any layers, we melt it, we then put it into another furnace, we filter, we chill, and then we shred, and then it can be turned into aluminium ingots. So it is around 95% lower in terms of energy costs. Other than the cost of it, why is that a positive thing? Well, the majority of the energy would probably come from burning fossil fuels. So by not doing that, we're reducing the amount of greenhouse gas emissions. Where would aluminium go if it were not recycled? Repetitive, let's get straight in. It would go into landfill using limited space. If the ore we extract aluminium from contains sulfur, what might we make during extraction? What environmental factor would arise? So we're going back to some old work here on the environment. We're going back to the end of the Earth's atmosphere chapter, and it would be sulfur dioxide we would make, and that would cause acid rain. We're now going to move on to copper. What have scientists done to maximise how much copper can be extracted? To remind you, we're thinking about how to extract copper from low-grade ores. The two methods that we have learnt about earlier within this chapter are bioleaching and phytomining. And you do need to know the details of them, so go back and watch if you're unsure. If copper is extracted, what are the environmental implications of the large energy requirements for the process? It might be we need to use fossil fuels to generate that energy, so there would be more greenhouse gas emissions. A little bit of repetition again, same ideas in all of these different areas. Where would the old copper be placed if we didn't reuse it or recycle it? It would go into landfill. And as we've established in all of the other previous examples, that would mean landfill would fill up and we would have to find new places to put landfill, which is increasingly difficult to do. Pure copper is vital for electrical wires. What process did we learn about in previous chapters to get pure copper, to ensure its purity? The process we use is electrolysis, and there's a whole video that goes through how that copper is purified. With impure copper, the copper being converted into copper ions, those positive copper ions being attracted to the cathode where they are reduced to copper. And the half equation we would get at that cathode, well, copper 2 going to copper, it's gaining electrons, which tells us its reduction, and the copper ions are positive, which means they are attracted to the negative electrode, and as I've already said, that means this reaction would take place at the negative electrode, the cathode. That takes us to the end of this video and the end of this topic. Thank you for listening, and goodbye.